my name's Mark Tor. I'm from SAS. I look after our EMEA and AP Center of Excellence for the analytical platform, which covers pretty much our entire technology stack. Alongside me, I've got two of the colleagues from my team here. I've got Ivar Moen and Schnur Jensen. What we're going to do today is we're actually going to, first of all, very quickly give everybody a bit of an overview of who SAS is, because we are not the airline, and we're not surfers against sewage. These are the common things. We're also not special forces from the UK, although maybe in a former life we were there. How many people in the room actually know SAS? Do you mind just raising your hand? Okay, so actually most people, so I won't spend too much time here. So those of you that don't know us, we've been around for about 40 years now, coming up to 40 years. We're very focused on the areas of data management, analytics, visualization, but also we have vertical solutions, things like fraud solutions, risk solutions, cybersecurity solutions, and things like that. We're actually the leader in 17 of the Magic Quadrants that Gartner has at the moment. So in their lovely Magic Quadrant grids, we're in 17 of them in the top right. There's pretty much no other vendors that's in that same sort of space. We've got 400 officers across 135 countries. So we've got a very large footprint. So we have local people in pretty much every country. Per IDC, we actually have 38% of the advanced analytics market. So this morning, when Forrester was talking about this predictive capability, that's obviously where SAS is very well known and where we've got an absolute domination of the market in that sense at the moment. We reinvest 25% of all of our revenue into R&D every year. But actually what a lot of people don't know is we make a great deal of our revenue off data management especially. So because if you think about it, in order to be able to do analytics, you first of all have to get the data together, you have to get it into the right format to do things with it. And so we have a great deal of our revenue coming from data management. So you might be wondering, of course, why is SAS at a Hadoop conference, okay? And the simple fact is that as a company, we want to be the #1 vendor for analytics on and around and in Hadoop, okay? And I'll talk more about those concepts in a second. I'll just skip past this Gartner Magic Quadrant. This is just one for the advanced analytics. This is one of the latest ones. You'll see that SAS has the highest ability to execute and one of the best visions. That's also tied to our direction that we're moving in supporting Hadoop. But support of Hadoop isn't instead of something else. It also includes all of the support that we're also providing for all of the traditional RDBMS vendors. So we're not abandoning that. We want to be able to run SAS and run SAS analytics wherever that data is, okay? We've been out in the market for a little while. We've had a number of different products out that support Hadoop, and we're actually going to not do too many slides here today. There's about 12 slides I've got. We're actually going to show you some product and do some live demos, because I think a demo speaks far more than I can do in slides. One of the things that we noticed over time is, of course, people want to operate either with much larger data sets with the same type of analytics, which means you need more processing capability and power, or we want to use the same size data sets and we want to do more complex analytics, which requires more computation. And Hadoop and the commodity hardware that generally comes with is actually a very powerful vehicle for running analytics and for doing business intelligence. So our feeling is that over time, a lot of the heavy-duty modeling, a lot of the modeling that people do on the large data sets, or even on a medium-sized but more complex analytics, will gravitate towards the Hadoop platform. So for us, Hadoop is very strategic. With Hortonworks, we have joint engineering. We're one of the partners of Hortonworks that actually has Hortonworks engineers sitting in our headquarters, working together with Hortonworks so that we're making sure our products are very tightly integrated. We're Yarn certified, so most of the things that you'll see here play nicely inside of the cluster. Now, SAS has been around for a long time, and as we looked into Hadoop and what we were going to do on Hadoop, one of the things that became very clear is skills is a big issue in the Hadoop world. So we went out with Intel, and this is a study in the Nordics, but there are other studies out there. And there's a link here you can follow through. You can download the presentation afterwards. And we talked to 300 managers across the Nordics around what they were doing around Hadoop. And in fact, most people were buying it for advanced analytics, data discovery, or an analytical lab, which is good. 22% wanted to use it to speed up their ETL type processing. But when we pushed a little further as to why it was that this thing maybe wasn't going as quick as we were hoping it would go, it was all coming down to resources. So the challenge that we're faced with in the market is a massive skills shortage. Now, of course, everybody that's here, or a lot of people that are here, are trained or are very focused on getting those skills up, but there aren't enough to go around. Even if everybody walked out of this building, all 1,000 plus, with those skills, there's still not enough to go around. So the break in the Hadoop world isn't necessarily Hadoop, it's going to be the skills to support operating in that ecosystem. So one of the things that we've been working on is how to take away the need for all of this coding. Now, that doesn't mean we want to remove the need for skilled Hadoop people. They're still going to be needed to do other things. But if we want these Hadoop clusters to go and be used en masse in organizations, just in the same way we had to put some layers on top of databases and other things, we have to think about doing the same in Hadoop as well, right? So I'm not saying we're going to put the Hadoop data scientist coder out of business. In fact, we have products that support that type of user, but we have to democratize access, and we don't want all of the people in the organization having to learn tools like MapReduce or interfaces HiveQL, learn all the HDFS commands, learn about Uzi, Scoop, and technologies like that. So one of the things that we've been focusing on the data side, and we'll show you this, and I'm going to focus on that, but we're also going to show you some of the analytical and visualization pieces, is how can we help people get data into the cluster? How can we help them do some management of the data, some transformation of the data, some data profiling of the data inside the cluster? How can we get them to be able to do that in a self-service way without always having to come back to IT? So if we think about a data scientist, most people do not actually like that more manual process. They want to be playing and being creative. They want to be investigating the data, finding things out. So what we're trying to do is take that early cycle stuff and make it a lot easier. And we're going to show you a demo of that in a second. So really what we're looking at is how can we put interactive data preparation tools in front of the tool set that we already have, which is for interactive visualization and exploration, and also interactive modeling. And on top of that, we have a programmatic interface to enable you to actually do data science type programming work if that's what you want to do. Okay? So inside of SAS, we talk about our work with Hadoop in 3 different ways, and this is important to phrase certain things. The first way we talk about is from, and that's more of a traditional mode. So we have our Hadoop cluster in a corner or in a big server room or wherever you want to put it. You're putting some data in Hive, you're putting it on HDFS, you're just going to access the data just like you would do any other data source, right? You pull it across, you get the data back into your SAS system, and you operate on it just like you always would have done. The second way we're going to talk about is with. And in fact, the demos that are going to be shown by Schnorr are going to show you some examples of with. And what SAS has is SAS has an analytics platform and engine that sits on the Hadoop cluster. And it will lift the data out of HDFS into memory, and it will give you a much more complete set of math libraries and capabilities. And it will give you all of these highly interactive visual interfaces to work with this data interactively in memory. Okay? So we utilize the CPUs and the memory of the cluster in that sense. The data lives in HDFS and it's just lifted. And the last piece that we talk about is in. And this is actually another level of working where we actually have taken a lightweight version of SAS, if you like, and we've put that onto each of the Hadoop nodes. And then what you can actually do is take certain SAS functionality, and you can execute that where the data resides on each of the nodes as part of, say, a MapReduce job, for example. So later on, you're going to see us do some work with data profiling. And that data profiling work that we're going to do is operating in this in mode of working, because there is no data profiling built into things like HiveQL. So we actually are running that with a bit of SAS smarts inside of this special lightweight engine. Okay. We also have a life cycle. It was interesting to see that put up this morning in the sessions. Obviously, you've got the data coming in, you've got to explore it, you develop some models, and then hopefully you deploy them out into your operational systems or wherever they're going to run, and then you monitor them over time, because anybody that's in modeling knows as soon as you deploy it, it starts to degrade. You need to monitor it over time, see if it's still performing, have a replacement in mind, and keep experimenting. So we talk about preparing data inside of analytics, and we're going to see inside of Hadoop. We're going to see that from Ivor in a second. And then we can move data either into Hadoop, or we can move it from Hadoop into a SAS environment, or from Hadoop to something like Oracle or DB2 or Teradata or another Hadoop cluster. Then once we've got the data, we can explore that data in memory if we want to. We can lift it into memory using this with capability. Then we can develop models, again, in memory if we want to. And then we can deploy that out. And when we deploy, we're generally doing things like generating some score code or something, and we're deploying that. We can put that into the lightweight engine as well, and then we can do the scoring actually on each of the nodes without ever moving the data. So it's extremely quick and very scalable. Okay. So this is kind of the life cycle, and we have these 3 different approaches with different tools, and when we work with customers, we generally sit down and we try to work out what the best mode is. It's 3 different design patterns, if you like, of working with Hadoop. And the right one depends very much on what the customer's trying to do, what the challenges you've got, how much data you've got, what hardware you've got available, and lots of other things. So the demo that we're going to do here is a little example of an online e-commerce shop. And we kind of set something up that they're having difficulty to keep up with the profitable customers and keep them returning to the site. So what we're going to do is we're going to try and figure out the reasons for those customers actually abandoning their shopping charts. We're going to do all that using these tools through parts of this life cycle. So with that, I'm going to stop talking and hand over to Ivo, who's going to start showing us some software. And the first thing he's going to show us is a new product called SAS Data Loader for Hadoop, which is you guys can actually all go out to the SAS website, and you can download this thing for 90 days as a free trial. So you can go and get it and play with it yourself. If you need help to get to that link, come by our stand later, and we're happy to give you that link directly. Completely free. Download it, play with it. We're sure you're going to love it. That's why we've made it available. And with that, I'll hand over to Ivo, who can run us through the first part of the demo. Okay? So we're up.
Okay, so is my mic working?
No, have you turned it back on? It's on. There you go.
Hello?
Yeah.
Oh, yeah. So what we're looking at here is the SAS Data Loader table viewer, and it's a web log table. And what we can see here, we can see the date and the time and the IP address of visitors to this online retail site and the URL that they're accessing. We can see some product data from 3 different levels, and we can also see a page name that they're accessing. But we don't know anything about this data, and so we can use Data Loader then to do some data profiling to discover certain things about this data. So if we switch into Data Loader itself, we can see here that we can use Data Loader, which is a very simple HTML5 user interface. We can use it to query or join data. We can sort and deduplicate. We can transform data that's sitting in Hadoop, transpose, but we can copy data into Hadoop from anywhere, and also copy data to anywhere from Hadoop, and do data cleansing type activities entirely within the Hadoop cluster, utilizing our data quality embedded process technology that sits inside every node in the cluster. And then finally, we can load our data into the SAS laser server, which then is the part where I hand over to Snor, and he'll show some data visualization and advanced data analytics. But we need to have a look at this particular table, that's weblog data, and I ran a profile earlier, so we can actually have a look at the report, the profile report for this table. To have a look, to get a general idea of what this data consists of. What we see here is we see some metrics, uniqueness. We can see there's 1.5 million rows of data. We can see pattern analysis, null values in the data, and certain blanks. But upon closer looking, I discovered a problem in this data, and that's what I'll show you now. If we look at the product level, what I noticed was that we had clothing, and we had clothes, and with a little bit of additional investigation, it was discovered that it was to do with the way that the website is organized. It's organized differently for men than it is for women, And so that's a problem in the website that can get fixed. But this is the data that we've got now. So we need to actually do a little bit of cleansing prior to doing some sort of analysis on that data. Okay, so to cleanse, we can use the cleanse directive in SAS Data Loader, which we can select that table. And do some standardization because we want to standardize that particular column that had the mixture of clothes and clothing. So we select that column. That was product level 2. And as previously I created a little standardization scheme that get added to our quality knowledge base that got distributed across the Hadoop cluster, and that can actually do that particular cleansing activity. And one other thing that I didn't show is that we have a problem with the third level product data, in that we have a mixture of case. We have upper and lower case. We've got some strange punctuation and some other strange anomalies. So I've got another little standardization scheme developed which will clean that up. And okay, so we'll run this cleansing process and create a cleansed version of it.
So Ivor, just while you're doing that, that's running against Hive tables, right? So
yes,
it's Hive in and Hive out, just to give you this. There's no data coming off the cluster when this is executing.
Yes, and so this is now processing, and it's utilizing this quality knowledge accelerator that's distributed across the Hadoop cluster. And so while that's processing, I thought I'd give you a brief overview of the actual capabilities of SAS Data Loader. We can break it down into 5 sections here, where the first section we're acquiring data or discovering data, copying data to Hadoop from anywhere. We're profiling data, that's the activity that we have currently seen. We can do identification analysis to identify certain columns. For example, is the data in one column actually a phone number or an address or a name? And we can do general querying of the data. Ultimately, we're accessing data, moving it into Hadoop, and assessing the data structure and content. Next, we can transform that data. We can query, we can select columns, we can apply filters, map columns, we can do sorting and ordering, we can calculate new columns, transpose data, aggregate data, but ultimately we're selecting data of interest, manipulating it, and structuring it into the data format desired entirely within the Hadoop cluster. Then we're cleansing the data. We can validate data, we can parse data, make new columns from unstructured columns, and ultimately standardize data, which is the activity that we're currently running. So we're putting the data into a consistent format. Then we're integrating the data, joining it with other tables, creating match codes, sorting and deduplicating, aggregating the data, or running regular SAS programs against Hadoop data. So we're combining data sets here, including data that has no common key, and removing duplicate data and creating new data points through aggregation. And finally, we want to deliver that data. We want to load it into the SAS laser server for further data visualization and analysis, which is where Snorre will show you that part. We're creating tables when necessary, or creating views of tables, and copying it from Hadoop to somewhere else when necessary. So ultimately here, we're loading data sets into the SAS laser in-memory analytics server, or we're creating new Hadoop tables and deliver other data to other databases and applications. But if we switch back into Data Loader, we can see here that our process of cleansing is now completed. So we can have a look at the results here. And what we'll see as it opens into the table viewer is that we've got 2 new columns generated here. We've got the standardized columns And the first one, we'll see that indeed we've now cleaned it up. We've now got just one instance here. We've got clothing. We've eliminated all the items that had clothes. And in the second product level, we have no problems any longer with upper and lower case or strange punctuation. We've got data in a nice clean form, in a form that Snore will have less problems with as he moves it into the analysis phase. So without further ado, we can take that output table and load it into the SAS laser server, whereupon I'll hand over to Snore. So
just before we move over there 1 second, while you're loading that, there was
Yep.
one question from here. Maybe we could just quickly take it.
Yeah, so what you're doing there when you're cleansing the data, is that like creating Hive queries under the covers and cleansing it that way? Did you say you were
Well,
so just before, because it's on video, just to repeat it, are we generating Hive queries under the covers when we're doing standardization?
in many cases, yes. But it's not the only thing that the data loader is generating. Data loader is generating a language called DS2, which is the next generation SAS language, which is designed to run in a distributed mode across multi-cluster environments.
So maybe we just stop at that level and we follow up afterwards. So effectively, the deduplication is not using Hive. Okay, that's the simple answer to the question. But we do, when you're doing a query of a table, we're generating HiveQL behind the scenes that you, in fact, could cut and paste. So if you want to use it as a rapid prototyping way to build HiveQL, it can be used for that. If you're very advanced on HiveQL, you can use it to do the basics, hit the edit button, and then start adding your own extras around it. But the actual deduplication is value-added stuff that we bring through our lightweight engine in the cluster.
Yes. Okay, so...
maybe put it on hold, otherwise we won't get through the rest, and hopefully we have questions at the end. So the laser server, by the way, is our in-memory analytics engine. We call it the laser server. Just it's been mentioned a lot here. It's the in-memory platform. It's very similar in some mindset to what you see with Spark. Okay.
Okay, so I'm just going to load this table that I cleansed into the SAS laser server so that Snore can take over. I'm going to replace that existing table, if it already exists, and start loading that. At this point, I'll just switch over to Snore's environment so that then it'll be there by time he's ready to go.
Okay, thank you, Ivor. My mic turned on. Yeah, very good. So Ivor loaded some web traffic data into the laser analytics server, which I can then start to analyze. Using the laser server has a number of advantages. One is obviously that data is stored and persisted in memory, making any subsequent analysis very, very fast. And it also has the advantage that we can have a number of multiple users, so me and my colleagues working on the same table, which is loaded into Laser. So it has a number of very, very nice technical features. What I will be showing you today is a quick overview of what is going on in these web traffic data, and then moving on to building an advanced analytics model trying to predict whether or not people are abandoning what they have put in their cart on our website. So to have a quick look or an initial look at what is going on in our website, I'm going to do something which is called a path analysis. And path analysis is not only restricted to doing analysis of traffic online, but can be used in a number of other instances. So to that, I'm going to use something which is technically called a Sankey diagram, where I can sort of picture the events that are taking place. And in this case, an event is a page on my website that is being visited. So I'm going to drag and drop page over here as my event. And then there is a sequence order. So in which order did they visit the individual pages? And I have the sequence order down here. And then I need to be able to identify each transaction. So I have a session ID as well. And once I've put this in here, it goes about updating the graph or building my path analysis for me. And let's see if we can perhaps expand this a bit. Okay, doesn't seem to be the case, but this is the most important part. Let's scroll down here. So we see we have a number of people coming into our landing page. So this is our welcome page. We can see that we have roughly 25% of the customers coming to our landing page immediately dropping out again. And this raises a number of interesting questions. Why are people coming to my landing page if they drop out immediately? Does that mean that the way that people are directed to my web page is wrong? Am I doing the wrong online advertising, etc., etc.? We can also see some other interesting patterns up here. So for instance, if we go and have a look at this particular webs feature right here called Deals. Where was it? There it was. And we can see that we have a number of visitors coming to the page around, concerning deals, and we have a large number of customers dropping out immediately. And that might not be a problem in itself, because it might be quite natural behavior for people coming to our website, checking out which deals are available today, and if there is nothing that is of interest to them, they drop out immediately. So no issues there. If we look at the overall plot, we see that there are a lot of, you could call it noise in here. And that is because I've just plotted all the data as is. So what I can do now is I can try and work with reducing part of this noise. So I'm just going to switch off the auto update. I'm going to increase the minimum frequency. So I'm not interested in, say, a path that was only taken once. I'm also only interested in the top 200, or top 20, sorry. And I want to highlight or use a feature called compress, which sort of takes some of the similar looking pages and sort of build one statistic for all of those. Then I'm going to update my plot again. So now we have a plot with perhaps a bit more signal in it and a lot less noise. And I can continue this process. I can merge more of the some of the pages into a higher category. So I have pages for product visits, product search. I can merge that into one page for products, etc., etc. But what I'm interested in is up here, where we see people adding things to the cart, dropping out once they've added things to the cart. And we can see that we have people dropping out during checkout, etc., etc. And this is potentially a very, very big issue for me, because we have people spending time on our website, putting things into the cart, and then first of all, for some reason, they abandon their cart. It might be something they do by themselves, or it could be technical issues. But perhaps also more severely are people being dropped as part of the checkout phase. So this is where people have put items in the cart. They have gone and found their wallets. They have taken out their credit card. They are about to punch in the numbers from the credit card, and then all of a sudden the transaction stops. So this is potentially a very, very big issue for me. So this is something I need to do something about. And to sort of move over into the next round of analysis, what has been going on here story-wise is that we've sent out a questionnaire to people asking what are the reasons for abandoning their cart, what are the other issues you have with our website, etc., etc. And the most prevalent feature or the most relevant feature or answer coming back from our customers is that there seem to be some technical glitches on our website which kind of prevents people from completing a transaction. So this is something that needs to be looked at. So what I want to do now is I want to set up a predictive model that kinds of, based on behavior on the website, calculate a probability for whether or not people are abandoning their cart. Because if I am able to sort of identify certain factors which increases the likelihood that people are abandoning the cart, then I might have something I can do something about, either by removing technical glitches or optimizing website performance, etc., etc. So what I'm doing here is I'm building a logistic regression, and I have a number of options for building a predictive model in here. What I have is I have what is known as a target variable, indicating whether or not people have abandoned their cart. So it's a binary target variable. So in here I can use things like a decision tree or a logistic regression model to try to explain the probability of abandoning the cart. So what I'm going to do is I'm going to use certain features from our website, so the number of clicks and the number of minutes they spent, orders, and the value of items they put in the cart. Let's put them over here as continuous effects. And I have my binary target here, and move it over here as a response variable. So right now it's building a logistic regression model for me, where we can see that all the variables that I entered as potentially explanatory are all significant, etc., etc. And I can get an estimation of, or an assessment of my model performance. So this is all well and good, but being an analyst, being an ambitious analyst, I want to see if there are ways of improving model performance. So one very, very cool feature I have in this tool is that I'm able to work with various segments in the data and build individual models for each segment, which is a very, very nice feature. The tricky thing here is, of course, how do we define the segments? The way I'm going to do this in here is I'm going to build the segments built on data using cluster analysis. And I have some information about the customers visiting my website. So I have age, family size, gender, and the number of previous visits to my website. Let's see, before I do that, I want to limit the number of clusters to 4. And then let's see what comes out of this cluster analysis. A cluster analysis can be very, very revealing if we want to get a quick overview of what's going on in my data. So it has built 4 clusters for me, and I can see some information about my clusters down here. And if we click, for instance, here, we can see that this seems to be, I forgot to mention that gender is coded 0, 1, 1 being females, males being nobodies, so we are coded as zeros. So we can see here that these tend to be relatively young females visiting our sites a number of times. So this is one segment that I have in my data. Another segment down here, again, females, young females again, and at the very bottom here, I have the male segment, where we can see where the segment has age all across the board. So basically every male is down here. And we can see that in kind of business terminology, this could also be a major issue for us, because it turns out that a lot of the males visiting or male customers that we have only come to our site once. They only pay us 1 visit. So this might be an issue, and we can start investigating how much they buy for, etc., etc. What I wanted to do instead was kind of use this segment information in my logistic regression. So I'm going to right-click and derive a cluster ID variable. So now I'm adding another column to my original data with just a number of the cluster that the data is in. And I can go back to my logistic regression model and use the cluster information here as a group by variable. So what's going on behind the scenes now is that instead of just one logistic regression model or one predictive model for all of my data, the system is building one predictive model for me per segment. And we can see here that there are some of our larger segments where we have been able to increase the performance of our model measured both in terms of R squared and in terms of lift. So this is the way we work with the data. Highly interactive, switch back and forth, generate new ideas, try them out, etc., etc. So that was basically
That's good
from my
because
side.
we're kind of close to the end.
Over to you, Mark.
What we just showed there is very much the visual way of working with things, the interactive way. That same table in memory and the same things we were doing visually, you can do programmatically as well if you've got data scientists that want to actually write code and have a lot more control. And that interface, that engine does have things like a recommendation engine inside of there as well. So while we focused here on logistic regression and things, it is much broader than that. So what you saw there was basically some elements of going around this life cycle. We talked a little bit about data loader. Clearly, we kept it very short because we don't have much time. Happy Ivar's down at the stand. Go and talk to him. He'll run you through an end-to-end demo. We talked and showed you two products there. Visual analytics and visual statistics were the two things that Schnorr was working with. There's a few other things around this life cycle we haven't covered off here, but effectively for us, Hadoop is an incredibly important platform, and we really do want to be the interface or the technology that you're using to drive the management, transformation, exploration, and analytics on top of your Hadoop cluster, okay? Where possible, we leverage native Hadoop capabilities, as we talked about HiveQL in certain circumstances, Oozie and Scoop to pull data in from databases. So we're not reinventing the wheel, we're just providing the interfaces that make it a lot simpler for people to get going. Okay. We do talk about supporting this entire journey at SAS. We think that's very important because a lot of the point projects that you see coming from Apache are great, but they're very often created on their own space, and there isn't that integration and smoothness through them. So the idea that we showed earlier where we could generate a cluster ID and we could actually take that back in and use it to actually then generate models per cluster ID, that's something that's incredibly powerful. And that integration is pretty much end-to-end as you move through this. So you can do the exploratory type work that we showed a little bit of here. And then if you then want to take that same model that you created in a Hadoop world and publish it and go and run it inside of Teradata or SAP HANA or wherever in your operational systems, you can take that and run that exact same model in those systems. That's also a massive benefit of the approach that SAS is taking. Okay. With that, we're kind of towards the end of the session. I do know that there was one question that the gentleman at the front had, so I'd like to come back to him because he was very patient while waiting, so feel free to fire away.
Yeah, thank you. What I know is that if you want to load data into SAS later, it needs to be in SAS HDAT format.
No, that's not actually true. So, I mean, that's quite a detailed question to answer in a big group, but effectively what we have is you can directly stream your data into Laser, okay, and that will load. The other thing that you can do is SAS has a patented effective memory mapping capability. And what that allows us to do is when we're loading data in parallel, we can actually put a memory mapped copy of that, which is the SAS HDAT, into HDFS, and then we can just lift that. So basically, we can lift data into memory as fast as physics allows us, okay, if you do HDAT. If not, you have to stream it in. So it's a trade-off of going towards a format that lets you lift or being a little bit slower at getting it up into memory.
And what about the SAS access to Hadoop? I understand that through these components, you could load data which is not in SAS HDAT format into Laser. That's what I understood.
So the access to Hadoop product is generally used from a traditional SAS environment, and it's used generally, it should really be called either access to Hive because it's primarily accessing Hive. You do have an access to Impala as well if you're in the Cloudera world. It also reads and writes HDFS files and things like that. So access to Hadoop is not needed, again, in that instance for getting things into Laser in that instance. Okay. Are there any other questions?
Sorry, with the laser that you just showed there, was that taking data from Hadoop and putting it into like the side server? Is that what it's doing now? Is that running inside Hadoop?
So I think the question was, when we loaded the data into Hadoop, did we put it into a side server or did we put it physically in Hadoop? And the answer is it could be either. Okay, in this particular case, it's effectively, we'd moved it off into another Hadoop cluster effectively, because the data loader example we were running actually was running against the Hortonworks sandbox, just to give you an idea. So we ran that against that, and then we loaded it into a different environment for the memory piece, because clearly we didn't want to run on a single machine.
And so the memory, so you've got all the memory that's available on the cluster, but if your data set size is bigger than what's available on that cluster, you have to sample, or?
You could either sample or you could increase the size. We do have some compression capabilities, which is a trade-off again of performance against compression. So ultimately we offer either alongside, i.e. on the same cluster, or you set up a separate cluster, but we're also Yarn certified. So basically when you establish our in-memory platform, you state which resources it's got, so it won't contend with the rest of the cluster. So it will play very nicely within a shared cluster. We do see some customers liking to have a separate math cluster for various reasons. Okay, I think we're blinking on overtime, but we're into a break anyway, so I'm happy to take another question.
So I assume that user interface generates a bunch of code under the covers. Is there any way that you can actually test that code separately?
So when you say user interface, if you were talking about data loader, the answer generally is yes. It does generate code, and it is code that generally you can take and you can run independent of the interface. When we talk about what you saw with the visualization of visual analytics and visual statistics, that isn't actually generating code. It's actually calling actions. The laser server is an action-based stateless engine. It's calling actions, and the state is maintained on the client side. That's how we have one table, but we can have multiple people doing things and retain just their piece in their sandbox. The outcome you would get is a model, and you can export that model. And the model that you create, you can then take and put somewhere else, manage, edit, do whatever you want to do with. Okay. Any last questions? Once again, Data Loader for Hadoop is free for you guys to go and download. Please feel free to go and get it and try it out. Give us your feedback on if you like it or don't like it. It's on our website. And thank you very much for your time today, and have a great break.